What I plan to do is use this ATtiny Arduino module that I can program a countdown timer in it and control this relay. Then this relay will be able to shut off the fan, and then what we're going to do is when the power goes back on or off, it will reboot this and I'll be set up for another time cycle. Here's a situation where I have a standard switch and it turns on, it runs a fan. That fan will run and that fan will cycle forever unless I implement a timer switch, which in this case I can't do it. It's not this particular case, but I have a case where I can't implement the timer switch. So instead I have to have another way to do a countdown timer. So what I'm going to do is allow the switch to be turned on, the fan to run, but then after a certain amount of time it's just going to time out and shut the fan off. And the only way, the switch will remain on, but the only way that you'll be able to turn the fan back on is to cycle the switch, and it will turn the fan back on again. Now we're going to simulate turning on the fan. I don't have an actual fan here, but I have a drill motor. I'm going to lock this drill into the on position. The next thing we're going to do is apply power to this, to the Arduino and to the relay. Of course, the Arduino is going to take a while to boot up, and during that time we're going to have to run the drill motor just with this relay until the Arduino can boot up and the countdown timer can control. So there's a LED light right here, and that LED light is going to dim and then it will become brighter when the Arduino takes over the countdown timer. I'm going to plug this in now. Now you can see the light just got brighter. So this is taking over the control. Let's take a look at how this system's going to work. There's a wall switch here that's going to supply power to the 5-volt supply, which is going to power the Arduino, which is going to set up a countdown timer. And at the same time, the wall switch is also going to provide power to the fan via this relay module. So we have a 5-volt power supply here providing power to the Arduino module, and then there is an output pin here that's a signal. We have to do a off. Off is a high signal. It's a +5, and on is a low signal, or 0 volts. That is the standard for one of these relay modules. So there is oftentimes a setting right here that will allow you to do a high based on, but we're going to choose the default with a low based on. So there's the input from the microprocessor, and then we also have the minus and the plus signal. That's just to supply the power, the minus and the plus, and then we have a signal input. And then from the output side, all we're doing is switching the line side, not the neutral, but the line side. We're switching that and turning on the fan. So the other thing is we need to implement a resistor across this ground and signal line. So when we power up, and this Arduino is powering up, we pull the signal line down while this thing is powering up, and that will keep this relay on. And you might need to play around with the values, the resistor values, to get that to work. Here's a cheap, I think it's called a Decade programmable resistor board that I use to calculate the values of the resistor. So you have to just play around with the correct pull down value, I think, depending on which module. For instance, this module, this relay module, might be different than this relay module. And you can see where I've implemented the resistor right there. What I'm doing is I'm just taking the I'm just putting a resistor between these two, the signal and the ground line. Please let me know if you have other solutions. I'm using this ATtiny because I had it laying around. I like this module here. It's a D1 mini, and it's a small processor. They're really cheap, and they also have Wi-Fi. I previously was using these modules here, which are occupancy sensors, and I really like these things. However, they require a neutral, and they also have the problem with consuming electricity all the time while they're sensing. And with the switch model that I'm using, we don't have that problem. When the switch is on and it times out, yes, we are consuming a small amount of electricity. However, in the normal case where you just switch on and off the fan, the person switches on and off the fan, we don't consume any electricity at all. So now we'll look at the code. First of all, I'm now running an 8266. I had some trouble loading the Arduino, the other smaller Arduino, and so I'm going to run the 8266. Mainly my problem was using this IDE and loading the code into it, so I just said forget it, I'm going to use 8266. And usually when you make some changes in the processor, you have to pay attention to the GPIO pins. Some of them are pulled up and pulled down, and you just have to be careful. So as you recall, for this relay here, I'm doing a pull down on it and using that special resistor on it. And so it's not okay to use, for instance, GPIO 2. If I was to use GPIO 2 to do that pull down, you could see here that it's pulled up, so I'd be fighting against a pull down. And the problem is also if I had the pin low at boot, which is sort of my plan, right, because I have to keep the relay on, that would not work out well. So the thing just didn't boot. So anyway, always pay attention to what the wiring is on the GPIOs. Nothing's ever super simple, right? So it turns out that you can use the relay, and it turns out that GPIO 4 is just fine, and on the D1 Mini, GPIO 4 is D2. So D2, I'm going to use D2 for the relay output, and again, low is going to be on. I'm also going to use the onboard LED, which is GPIO2, and it's also a D4. And I'm going to use that to flash my lights, just for a flashing indicator. So what's happening here is I'm defining the relay and the LED as outputs, and I'm setting up a timer value unsigned long. So I'm trying to get I think 10 minutes of timer. So if you multiply all that out, you get 600,000 milliseconds. 1,000 milliseconds is 1 second, right? So anyway, you need to make sure that that is the correct type there, unsigned long, so you get the correct amount of precision that you need to set up the sleep timer. And so then what we're going to do is, after we set the outputs, we're going to if we're not finished, this whole thing is only going to go through once finished, right? This piece right up here. And once we are finished, we're not going to go execute this piece anymore. But let's say we're just powered up and just going through this loop for the first time. We're going to set the relay low, which we've already discussed. That means that it's going to close the relay and apply power. And then we're going to set the LED low, which turns it on. It's that's the way it is on the D1. And then we're going to delay the sleep timer, which is going to be that 600,000 milliseconds. And then after we wake up from our sleep, which will be that 10 minutes, we're going to write high to the relay input, which is going to turn the relay, we're going to open the relay and turn the light or the fan off. And then we're going to declare that as finished, so we won't ever go through this loop again. But if we're finished, we're going to flash the LED at a different sequence, so we'll know just by looking at the board that we're going to be timed out. And that is about it. It looks a little complicated, I know, but I think if you fool around with these microprocessors, you're going to come to love them as I do. Basically, they're just so flexible. And then you could easily put some code in here with a motion detector or some other things that you can do. Of course, there are off-the-shelf things that you could buy, but I couldn't find one that did exactly what I needed to do here. And a lot of the motion detectors right now are consuming, several hundred watts a year just for the overhead. And this seemed to be a low overhead option, and it was a chance for me to kind of try out my skills. And this is a very simple project. Thank you for watching.